Bruce,
I think I
Rick said
can
he tried to
look at
push
it
it through the.
Yeah.
Okay.
To do this long.
Fantastic, thanks for doing that.
Yeah, of course, no, I'm glad it came up, but.
Yeah. Yeah, it'll be
We should have
good.
been sooner, but yeah, I think you'll really enjoy it, it's a great opportunity, and I always do. But I agree, people want to go,
Yeah.
and again, I'm gonna resign, so, you know, you can step in if you want, see how you like it.
Yeah, yeah.
So, Tim, ready?
I think he is.
I am as good as it'll get.
Yeah, he mentioned that you already sent some comments. So
Well, yeah,
thanks
it's a
for
couple
that.
hours ago. But
Yeah. Well, it worked out perfect because I was able to read them, and hopefully we'll.
Well,
address
yeah,
them.
I might have a minute to look at it, just to see, I don't know, I have some big picture issues with that,
You want to check that? It is.
Good.
Just now?
Oh, it's really.
Oh, we can make this super good as just go.
All this stuff out.
Where did
Yeah,
you-
he did a nice job.
Yeah.
You didn't send it.
You know, that combination of field and lab.
So you slowing down yet with all these?
Trying to
No, you,
get,
man. How many theses you graduated now, 5 or?
this is, well, Tim today, Angela Thursday,
So
that'll be 4.
can we get a stream of the stream?
And I'm trying to purge
Really weird.
at this
Yeah.
point.
So it's like 20. Yeah, 20 seconds. That's not.
I mentioned all the senior theses.
Yeah, exactly. Yeah, no, I gotta,
I think everybody is kind of like early on.
yeah,
Yeah, this will be fun.
yeah. And like you
Okay.
said, it's a marathon. so-
Well, it's just, plus you get older too.
Yeah, exactly. Yeah, don't like to admit that, but yeah.
Give out PhDs when you're 21 and
Yeah.
have a decade of productivity.
Yeah, no, I started late, so I'm ready to slow down.
Grad school's not a lot.
Yeah. I think what really took more of a toll was my postdoc. That was a friend.
Yeah, mine was pretty easy. Work on my
I
work.
love it.
Yeah, yeah, that's nice.
And I was still on OSU, so I didn't even have to move.
If you
Yeah, nice.
check it,
So that's how
thing,
it
does it not
works. He
work?
switched completely the field.
Yeah,
You
totally.
feel literature and everything.
Yeah,
that-
in retrospect,
Yeah.
if I had it to do over again, I don't think I would have done that.
Yeah, but it was actually, that's really.
Yeah, it was.
Yeah.
That I,
Yeah, a lot of people do that. Hinkson did his postdoc, you know, he did behavioral territoriality and servers.
Oh, yeah.
And then and then he went and did a postdoc with Robert on hummingbirds.
Really?
Territorial hummingbirds.
I didn't know that.
Yeah, and he wrote a couple papers
Yeah.
on the generalities, you know, between them and how they maximize or minimize time.
Yeah, that's pretty cool.
Yeah, and that's why he did it, you
Yeah.
know. And I just, whoa, that's even, not even brain.
Yeah, right. Yeah, I know.
Walk all the way around.
Took me a good 25 minutes to find a spot.
That's true. Well, I used to be here when I was, had my permit for 3 years, but almost never
You used it.
1 out of 10 times.
Yeah. Well, that doesn't even really help you when it's just a license to hunt, really.
I don't need to be here as often.
Yeah.
what are you expecting?
I don't know. I mean, a bunch of my studio friends said they might show up, so it could be a whole bunch. I don't know. We'll see. Part of why I wanted this room, though, I've seen way too many defenses in IG 157, where there's 22 chairs, a ring of people around the back, and people hanging in the door trying to listen. And suboptimal. The projectors in there suck too. There's always like a projector cart situation. So.
Tried to talk Kevin into coming. I think the main deterrent was that he wasn't going to try to run his spots apart.
Yeah, well, and I thought Kevin would be worked for.
Yeah.
But I sent him the stream link too, so. Yeah.
Well, we don't know if it lived to die.
Totally candid, I think just it's been so reactive. Like I literally every time I'm at work I give a damn like, hey, here's what you gotta order.
Yeah.
And it's constant, like people are coming in and it ends up being like, oh, order that thing, order. So you know, and given the whole thing of subsurface, you know, if anything, now's the time for
What's going on with subsurface?
well they could or could not be closing
How are
or
you?
something good.
Good.
Have you not heard that yet?
No.
Oh,
I mean,
well.
I heard kind of like, rumors of it, but
Yeah.
nothing that was confirmed.
Oh, but yeah, so it's pretty well.
How are you doing?
Oh, we'll see. So
Since an hour.
here's that, and, you know, so we've got a bit of an issue. People are trying to go over that and Mendocino, but we're not really ready to take on that market share. I don't know, we'll see.
Keep it open like part-time.
Should be interesting.
That's what they're already doing.
Yeah,
so
like,
we'll see.
Even more part-time.
I'm not sure.
So it'll be an interesting
I
summer.
think it might have been during
working
the
there.
section of the zone.
So,
Oh, no.
I know. I think
yeah,
that's
we'll see what happens.
probably why it's so
Like
bad.
once summer, I think once we get into spring, then when people actually start looking at it, maybe it's a little more
Thank God.
kind of sorted and ready.
It looks
But,
awful.
we're having a lot of stuff
Is
right
it
now.
better than it was?
I know, I'm in
It's
Fort
getting a
Bragg this
little-
weekend for,
well, I'm not sure.
check research.
Yeah, we got the beginning.
Don't worry about it. I might try and revisit
Should
my
be
doctor
interesting.
tomorrow.
I think-
Not sure it is
Just
yet.
go ahead and go to Casper.
Cool.
You guys doing it?
Yeah, we'll be able to do
Confidence
that.
that
Casper
that
was
is very reassuring.
Casper's good.
I'm like,
Sure wasn't ready for
a really long time. I was actually
Well, so the thing is, again, it's gonna be, we're finally getting spring, which our Pacific high is kind of rolls around. We're gonna get them guys today, just right now, so hopefully it uplifts. Because because last year we had Pisaster, not last weekend, but 2 weekends ago. And it was here, and then they were, but it was like 45 minutes. It was the first real long event we had, and it was just here, and all this street. It's gonna be cool as fuck. Yeah, it's like 40, and I was like, well, because it should up all week. So the question is, if it's drop.
It was the first, like,
4 or 5.
I've heard so much about him already, and then
So
I
I would
was
imagine,
like, that, no, we
Casper's kind of
not
remember.
Yeah.
I bet you it's Russian.
yeah, well, I
And
guess.
Russian Bulls has
It's better.
Why would, I mean, if nothing, and so is Russian.
Yeah.
Yeah, perhaps I'll be there.
That's the whole
Saturday is it's like 9 at 3:10.
I really
So
like
the
it.
question is how much that's gonna do. What we have working to our advantage is boat ride is at 12:10 on Saturday and 1:20, or sorry, 1 on Sunday. So rather than it kind of peaking, when June, and our objectives are we can do mass brand gear, get the essays, and there are
I mean, you guys would probably do that, yeah, sit down and have 10 minutes, go back.
Oh, good, very good.
My goal
Okay, good. Good. I think some of the
So have you published anything?
It's great, and it's all transparent, everything is online, all the results.
Hello, how are you?
I used to do one.
I don't know what it'd be called.
I know how it goes.
That's one of the.
Like, I think I've done it once in my life.
I never heard of it.
Is that the word?
I'm not really a plant person,
That was the same as before.
Oh, yeah.
Well, that sounds good.
Starts under
You know, good old Ted Rice, like zip, zip,
Yeah, that's true.
My mom does so much.
That sounds like water.
It's, yeah, makes her living guys are like going out to get water and break their and so they're just like on guard ready for it.
I've never even tried that.
So it's weird, some of this is like but I'm more afraid
I think that's kind of all they care about.
I don't understand the biggest point in it. Nothing's wrong with it, I don't get it. You're not. Yeah. So we got to
check out it for you.
how is it not? It's right there. You're underwater like.
I don't.
I have to extend my thumb, you know that's, the seal that's like pregnant over by Trinidad, over by the dock.
Usually think about it.
Well, there is super pregnant, waiting to get served or whatever, but we went down there, we didn't see the seal, and I let her dog off the leash, and so she was like running around the beach like a real child, and doesn't like it, so what and at one point, she's across there, so naturally,
Oh, she was,
I
yeah, she was.
Well, and all the marine biologists agree.
and then someone older picked his head up, and I was like, let's not hold her. And so he's trying to play with the pregnancy with it. I'm trying to get the dog away from the pregnancy. And so I can't get away and legally close to the seal, so I fuck it, I want to run down to the dog. And so he did, and I
There's no deadline.
that much hit the tip of my thumb. I don't think she was. She's like yelling or something. She's like by
I had my one of the staff, he referred to tests as celebration. So like, it's not like he said that in class and it said test, like it said celebration of knowledge one. Like final celebration of knowledge. Yo, we had to
just point at it.
So he like just
Point at it,
committed
just
fully
like,
to like,
yeah, it's kind of crazy.
Yeah. Yeah, it works at the field.
Really happy to really know that my students.
Yeah.
Things are well. How are you?
I've worked inside lunches too big.
This is the splash.
I have not seen comments from Drake. I see Joe like, I mean, actually, it's not true. I see her. I feel like I see her.
I see it's kind of overseas.
On my committee, though, I see her.
Yeah, it's
That was the first time. I was still over here. Sounds like a new student.
So we're just waiting on a committee member who we're going to give 2 more minutes to show up, and if they don't, Tim fails.
I bet you Joe's trying to park right now.
There he is. Joe's here. Yeah, George, I know out of the bathroom.
All right.
All right, well, I want to welcome everybody here today to McClure's Thesis events. Thanks everybody for showing up and coming on what's a pretty nice day today in Humboldt compared to what we've been experiencing. Some of you may know this, but there's been a very recent tradition in my lab for me to roast my graduate students before they give their thesis defense. And so I'd like to continue, or at least in the hopes of continuing that tradition. I was going to prepare a roast for Tim, but Tim, I kind of had a lot going on this week, and a lot of TA stuff, grading, students. I had like a 7-day dive weekend that I went on. And just at the end of the day, I didn't really manage my time all that well, so a roast for you. I did, but I kind of threw it together last minute, and I actually just submitted it to you about 2 minutes ago. Did you get a chance to do that? Oh, no, you didn't? In that case, then I'll keep this brief, because for any of you who know Tim, there's one thing he appreciates, it's brevity. So, without further ado, I want to introduce Tim. So Tim came very highly recommended to me from a good friend of mine at Western Washington University as an already published author who worked on Pisaster. And so I had really high expectations for Tim as a graduate student. I was really excited to take him. And I will say this, his thesis has not disappointed at all. Tim did an amazing job on his thesis. You're about to see a really great combination of field and laboratory manipulations that's answering a really important and timely question with some pretty complex material. And Tim did a great job sort of embracing the community ecology aspect of this project. And I'm really excited for you guys to see his data. So I want to turn it over to Tim now so we can see the work that he's done.
Thanks for the introduction, Paul. I'll try to keep this brief as well. As Paul mentioned, I'm Tim McClure, and my thesis is about the ecological consequences of sea star wasting disease, and specifically non-consumptive effects and trait-mediated indirect interactions from the ochre star Pisaster ochraceus. I did most of this work here out of the Telonicher Marine Laboratory here at Humboldt State University. In this talk today, I'm going to go over some background of non-consumptive effects and trait-mediated indirect interactions. I'm going to talk about the questions that my thesis addresses, the experiments I used to address those questions, one in the field and one in the laboratory, and then talk about some of the conclusions we can draw from these studies. So first, some background on non-consumptive effects. Since the beginnings of modern ecological research, a considerable body of work has investigated the role of predation as a structuring force in communities. These are often known as consumptive effects, aptly named as they act through effects of prey consumption. These consumptive effects can also elicit indirect effects, which are known as density-mediated indirect interactions, again because they act via these prey density reductions. Together, consumptive effects and density-mediated indirect interactions form what are known as trophic cascades. And so a classic example of trophic cascades is the kelp forest here on the west coast, where sea otter consumption reduces urchin densities, and then the resultant reduction in urchin grazing then increases kelp productivity and biomass. And so the net effect is that otter presence indirectly benefits kelp forest habitats. And so consumptive effects of predators are clearly important. Predators can also have non-consumptive effects. Rather than the effects of prey consumption, we can think of these instead as the effects of prey intimidation. Non-consumptive effects are these induced trait changes, which increase the probability of survival for the prey, but they often come at some cost, usually in terms of fitness. And a recent meta-analysis has indicated that approximately 63% of the total predator effects on prey are actually comprised of non-consumptive effects. Similarly, these non-consumptive effects can also elicit indirect interactions, here known as trait-mediated indirect interactions, and again aptly named as they act via changes in prey traits or in prey behavior. Together, non-consumptive effects and their trait-mediated indirect interactions can impose what we call trait-mediated trophic cascades. And so a great example of that has occurred with the reintroduction of wolves in Yellowstone, where wolf predation threat increases elk vigilance, which then causes them to reduce their grazing behavior. And again, this reduction in grazing pressure increases the biomass and the survivorship of the resource. In this case, it's aspen. And so that looks something like this. The predator imposes a non-consumptive effect, which causes the prey to exhibit anti-predator behavior. In this case, elk increase their vigilance and they spend more time ready to react to wolf predation. And then that non-consumptive effect elicits the trait-mediated indirect interaction, whereby there's an indirect benefit to the resource. However, predator density is rarely, if ever, constant. And so theory predicts that prey responses to predators should be risk sensitive, and these higher risk situations should impose a stronger trait-mediated trophic cascade. Again, the combination of the non-consumptive effect and the trait-mediated indirect interaction. If there's more predators around, the non-consumptive effect should be stronger, and thus also should elicit a stronger trait-mediated indirect interaction. Prey sensitivity is also dependent to their prior exposure in their life history and their experiences of these higher and these lower risk situations. And so together these points have been described as a risk allocation hypothesis, which suggests that prey exhibit anti-predator behavior during these periods of high risk, and then allocate these risky behaviors such as grazing, such as mating, to these periods of low or background risk. While one might think that the absolute risk level influences prey behavior, it's actually about the relative risk difference, which actually affects the strength of this anti-predator behavior. And so despite this, a few studies have investigated the effects of predator density on the magnitudes of their non-consumptive effects and trait-mediated indirect interactions. So a low background situation would look something like this, where the prey become accustomed to a relatively low density of predators. And then in the acute pulses of predation risk, or these instances when the predator density is locally higher, this results again in anti-predator behavior. Again, elk increase their vigilance, which then has a positive indirect benefit through the trait-mediated indirect interaction. And so this is different from a high background risk situation, where the prey again are accustomed to the predator densities that they've lived through, but a marginal increase in predator density in this case isn't really going to elicit a stronger anti-predator response, and as a result, the trait-mediated indirect interaction from predator on the resource, which is normally beneficial, is reduced here. So in this case, grazing is increased. And so there are two key knowledge gaps in the theory and the work that's been conducted on non-consumptive effects and trait-mediated interactions so far. First is, are non-consumptive effects and trait-mediated indirect interactions actually important forces in natural unmanipulated communities? And secondly, what are the effects of spatial but also temporal variation in predator density on the strength of these non-consumptive effects and trait-mediated indirect interactions? And a wonderful system to study this and address these questions is here on the West Coast in the intertidal zone, where we have Pisaster ochraceus, the ochre star, predating black turban snails, Tegula funeralis. Throughout my talk, I'm just going to refer to them as Pisaster and Tegula here. And so Pisaster consume approximately 1/4 of the Tegula in their zone of overlap. However, they also elicit strong non-consumptive effects. In this case, Tegula will respond strongly to chemical cues in the water, and they'll exhibit an avoidance behavior by climbing out of the tide pools. As you can see here in this image, we have a whole mass of Tegula exiting the tide pool, and in the presence of their predator in close proximity. And again, this non-consumptive effect can also have an indirect effect in the community, specifically through the trait-mediated indirect interaction through grazing reductions. Another reason this is a great system to address these knowledge gaps is the recent onset of sea-star wasting disease. Sea-star wasting disease has decimated Pisaster populations along the West Coast. However, here on the north coast of California, that mortality has been variable, and so we have a patchwork gradient of Pisaster density along the north coast. And so, as a result, these mass mortality events due to sea-star wasting disease then could disrupt non-consumptive effects on Tegula, as well as the resultant trait-mediated indirect interactions on these natural communities. And so that would look something like this, where a reduction in the predator density should reduce the magnitude of the non-consumptive effect, which thus reduces the magnitude of the normally beneficial trait-mediated indirect interaction. So the 4 questions my thesis addresses. So first, the Pisaster non-consumptive effects on Tegula actually impose trait-mediated indirect interactions in the natural environment? Second, does increased risk difference between high and low risk situations affect the anti-predator responses by Tegula? Third, do the relative contributions of these non-consumptive effects increase with increasing Pisaster density? And lastly, do Tegula respond to Pisaster chemical cues at field-relevant concentrations in the laboratory? So first we'll talk about my field experiment, which I used to address those first three questions. So here in Dr. Bordeaux's lab, we have 4 field sites along the north coast of California, which I am indicating with these star icons. Along these sites is this gradient of Pisaster density I mentioned earlier. At Point St. George in Crescent City, there is high C-star density. Baker Beach in the Trinidad area is intermediate Pisaster density. And then Devil's Gate at Cape Mendocino, as well as Belinda Point in Mendocino County, both have low densities of C-stars. And previous surveys of these sites have indicated that there are significant increases in the proportion of Tegula in the higher tidal zone, along with at sites with increasing Pisaster density. So that's what I'm showing you here on the left side, the Pisaster density along the x-axis, and again that proportion of Tegula in the high zone. This is consistent with previous studies which have demonstrated this association between presence and then this avoidance behavior in terms of vertical migration. And these data also indicate the potential for these non-consumptive effects in the field. And so first, let's address this first question, whether non-consumptive effects in the natural environment impose trait-mediated indirect interactions. Most experiments of non-consumptive effects have been laboratory-based, or if they are field experiments, have used artificial manipulations in order to achieve these predator density differences. And so as a result, it remains unclear if non-consumptive effects produce significant trait-mediated indirect interactions in the natural environment. A recent study has also indicated that further work is needed to quantify non-consumptive effects from Pisasters specifically in the intertidal, as well as the trait-mediated indirect interactions they elicit. So again, here I've indicated the species in my system, Pisaster and Tegula. So I collected 64 Tegula from each of those 3 northern sites, Point St. George, Baker's Beach, and Devil's Gate, for a total of 192 snails I took back to the laboratory. For these individuals, I removed their shell epiphytes. I scraped off any barnacles or any algal growth on the shell, gave their shell an individual marking, and then I measured their buoyant and their dry masses. I measured buoyant and dry masses because I used soft tissue growth as a measure of the non-consumptive effect. If you recall, that a non-consumptive effect is something that increases the prey's probability of survival, but comes at an energetic cost. And so reductions in grazing reduce the energy available to Tegula, which then results in less energy available for somatic and for reproductive growth. Furthermore, gastropods often thicken their shells in response to increased predation threat. So I would also expect that soft tissue reductions, if they were actually associated with non-consumptive effects, would be associated with corresponding increases in shell growth. So again, growth allows us to measure the effects of these non-consumptive effects of Pisaster. Before I start the experiment, I starved them for 1 week just to ensure that their energetic budget was equivalent at the beginning of the experiment, and that some individuals weren't hungry and some individuals weren't full when I started the experiment. So to measure grazing, I created 24 15 by 15 by 6 centimeter cages out of 1/4 inch mesh. I used stainless steel mesh as a fence, and then similarly sized plastic mesh as a lid. And most cages are one piece, and if you want to open them up, you actually have to take them off the rock. So I modified this design a little bit, and I used reusable zip ties, which actually allowed me to open and close the lid, which was a nice benefit because it reduced the disturbance each time I restocked my cages. And so I also sealed, since the cage wasn't coming off the rock, I sealed the bottom edge with a split rubber tubing, creating kind of a gasket. This was important because it prevented Tegula from escaping out the bottom of the cage, and also prevented the influx of any additional grazers that were outside the cage. I put the cages behind wave-protected faces of large boulders, and around these cages I defined a 5 by 5 meter plot. And I'll talk more about the plots in a minute, but I installed the 4 cages in each plot as close together as I could in the center of that plot, in order to minimize the variation in tidal height and potential wave exposure. And I had 2 plots at each site for a total of 8 cages per site, so 4 cages per plot. I took those snails I prepared in the laboratory and I randomly assigned 12 to each cage, and I randomly picked from each site so that each cage contained snails from each source population as well. So I mentioned the predator, I mentioned the prey. The resource I used in my experiment was the stock kelp Pterygophora californica. This is actually a common kelp in the shallow subtidal zone and often washes up in the shore rack in the intertidal zone. And so you can often observe tegula grazing on the blades of the rack. Also, Pterygophora has a really hardy blade, which was suitable for my experimental measurements of grazing. And so it resisted degradation through other effects better than other algaes. And so I collected all the Pterygophora I used in my experiment from the shallow subtidal in Trinidad Bay. I purposely selected kelp from the same source location in order to minimize any sort of autogenic effects through expressed anti-herbivory responses or wave exposure damage or any other factor that might affect how it degrades. Once I collected that kelp, I took it back to the lab and I trimmed each blade right at the base of the blade and the tip of the stipe. And then I trimmed the blade so that it weighed 48 grams. And this then allowed me to have before and after weights for all the kelp used in my experiment, which allowed me to calculate these mass changes for the Pterygophora in each cage. I also had control cages made out of all plastic mesh, which were snail-free control cages. And then I subtracted the mass lost in those cages from the masses lost in my experimental cages, as any change in mass in my control cage represented environmental degradation, perhaps wave exposure. And so as a result, I had corrected kelp masses, which actually were indicative of tegula grazing and not some other site-level effect. So when I got to my field sites, it often looked something like this, where we often saw Pisaster in the immediate vicinity of the cages. And so just qualitatively speaking, we see clear evidence of anti-predator responses from tegula. Again, they're common responses of flight, vertical migration type of response. And what we often saw if Pisaster was in the immediate vicinity of the cage were clusters of tegula on the roofs of the cages. And so they had attempted to climb out of the tide pool and only made it as far as the top of the cage. And then we also saw them often trying to maximize the distance away from the predator. And they also often cluster together, kind of a safety in numbers kind of defense. This picture here on your right is the same cage just opened up, so there are even more snails like in that corner of the cage. And we could also visually see evidence of grazing. Tegula used their radula to scrape, and so what we could see were these indentations into the kelp where they had been grazing. And so just qualitatively speaking here, we saw evidence of anti-predator behavior from tegula. However, what we did not see were growth differences associated with non-consumptive effects. The soft tissue growth did not vary with Pisaster density increases. What I'm showing you here on the x-axis are each site from decreasing to increasing Pisaster density, and then the average soft tissue growth here on the y-axis. So while there were not significant differences in growth, what we did find was a significant decrease in grazing intensity with increasing Pisaster density. Similarly laid out here with each site, and now per capita cumulative grazing here on the y-axis. And so this indicated that decreased background Pisaster density did in fact decrease non-consumptive effects on tegula, which led to decreased trait-mediated indirect interactions from Pterygophora. Now I mentioned that I used growth to measure the non-consumptive effects. Here we did see distinct qualitative evidence of anti-predator behavioral responses, and so this trait-mediated indirect interaction via these grazing reductions was associated with this non-consumptive effect of behavior rather than growth. It also indicates that these non-consumptive effects and the resultant trait-mediated indirect interactions were in fact predator density dependent, which thus demonstrates that non-consumptive effects from predators can in fact be important factors in structuring natural communities. So for my first question, I found, yes, they do impose these trait-mediated indirect interactions in the natural environment. Secondly, I asked whether increased risk differences between these high and low risk situations affected the anti-predator responses that tegula exhibited. So recall the predictions from the risk allocation hypothesis, which were that prey exhibit anti-predator behavior during high risk and risky behavior during low or background risk situations. Their sensitivity should be dependent on their prior exposure to these higher and low risk situations. And as a result, it's the relative risk difference rather than the absolute level of risk between these acute and these background risk situations that affects the strength of their anti-predator behavior. So I addressed this by simulating acute pulses of high risk by increasing the local Pisaster density in one of the two plots above the site level background density. I accomplished this by stocking each plot bi-monthly with Pisaster to bring the plot total up to the Pisaster density from the high density site the year prior. And what this was approximately 1.1 Pisaster per meter squared. And so that resulted in about 26 to 28 stars per plot. And so each time I arrived to restock the cage, I surveyed the plot and counted the number of stars present, and then subtracted that from 27 to 28 in order to calculate how many stars I needed to add back to the plot, which looks something like this. Move stars from elsewhere on the beach into the immediate vicinity in this 5 by 5 meter plot. Again, only at one of two plots at each site. So what I've done is now I've embedded acute risk across a gradient of background risk, allowing me to test directly whether the risk difference actually affects their anti-predator behavior. I calculated effect sizes for non-consumptive effects and trait-mediated indirect interactions using standardized differences between the acute and background treatments for soft tissue growth, for shell growth, and for grazing amounts. I took the grazing and growth averages from the background plots, and I subtracted that from each of the cage averages for the acute plot, or the high-risk plot. And then I took the average of those four differences in order to estimate the effect size associated with that acute pulse of risk. This was a really important means of standardization because the differences in background levels of risks also affect tegula growth and grazing, and so I had to account for that. And what we found, showing you again these effect size differences on the y-axis, was that Pisaster additions caused soft tissue reductions at the intermediate density site, which was Baker's Beach. We saw a similar trend in the shell growth, which did increase at low and intermediate density. And so, while soft tissue growth wasn't significant at low density, the increase in shell growth was. And lastly, I found that Pisaster additions also caused significant grazing reductions at low and intermediate background density, and actually also resulted in a significant grazing increase at high density. Furthermore, the trend itself was also significant in this case, as measured by regression. So had a high level of fit for the relationship between Pisaster density and the grazing difference. And so what this suggests is that tegula responded most strongly to these acute pulses of Pisaster risk at the low background density, which supported the risk difference prediction of the risk allocation hypothesis. So we found for my second question, in fact, yes, increasing the risk difference does increase the magnitude of the anti-predator response from tegula. Lastly, I asked whether, or in my field experiment, I asked, lastly, whether the relative contributions of non-consumptive effects to overall predator effects increase with increasing Pisaster density. And so in order to evaluate the importance of non-consumptive effects and their trait-mediated indirect interactions, it's necessary to isolate the relative contributions of consumptive effects from non-consumptive effects. However, it is super difficult to quantify consumptive effects in the absence of non-consumptive effects because that would require eliminating the predator from the system. And so as a result, it's still really unknown if the importance of these non-consumptive effects and trait-mediated indirect interactions actually increases with increasing Pisaster density. And so in order to test this, I simulated predation using manual tegula removals. I randomly assigned to each cage pair, one cage to a manual removal and one cage to an unmanipulated treatment, which I named total predator and NCE only or TMII only treatments. And then in the total predator treatment, I simulated predation through these removals. I took one tegula from each cage each month which over the course of my experiment resulted in a 25% population reduction in the cage. And so this simulated consumptive effect is relevant to the magnitude at which Pisaster consumed tegula naturally in the field, again, approximately a quarter of the tegula population annually. And so it looks something like this, where the red cage indicates the total predator treatment, the blue cage indicates that trait-mediated interaction-only treatment. And so over the course of 3.5 months, I removed 4 individuals, and so the resulting population size in that total predator cage was 3/4 that of the unmanipulated cages. And so similarly, I calculated growth and grazing differences between the total predator treatment and the trait-mediated indirect interaction-only treatment. And in the absence of non-consumptive effects, or at low Pisaster density, in this case Devil's Gate, the difference between the total predator and the trait-mediated indirect interaction-only treatments should be significant, as we theorize that there are not strong non-consumptive effects acting at this site given the low predator density. And so as a result, this would indicate that a non-significant difference actually indicates the presence of these non-consumptive effects or these trait-mediated indirect interactions. Since I applied a comparable simulated consumptive effect at all sites, the difference between total predator and trait-mediated indirect interaction treatments allows me to assess whether or not the relative contribution of that trait-mediated indirect interaction changed. And so if that difference is non-significant, what that suggests is both terms in this subtraction are of similar magnitude, again resulting in that non-significant difference. So what I'm looking for here are non-significant differences in order to indicate the presence of these non-consumptive effects and trait-mediated indirect interactions. And for soft tissue growth, that's what we found. We found an increase in soft tissue growth at low Pisaster density. However, at intermediate and high Pisaster density, we did find that there was a non-significant difference between the total predator and the NCE only treatment. These non-significant differences indicate the presence of growth non-consumptive effects, and we also saw a corresponding pattern in the shell growth, where shell growth reductions occurred associated with my simulated consumptive effects at low Pisaster density. However, we again found non-significant differences at intermediate high Pisaster density, which indicates that the presence of non-consumptive effects.